One. So in this example, we're going to look at how to use linear functions to model data and answer some questions regarding the real application problem here they're asking us. So in this example, it says two cars, each with a different volume of gas in their tanks, start moving at the same time. However, the volume of gas in their tanks is used up at different rates. Assume the volumes are changing linearly. That part tells us that we're going to use a linear function, okay? So here's this little table here is telling us the volume in the tank in gallons. And so this one says that within 1 hour, the volume of car B's tank had 17.25 gallons and car B had 19. And then after 5 hours, they were driving for 4 hours. So obviously their gas was being used up. So it would decrease, right? Which makes sense. So car A went now at 5 hours, now had 14.25 gallons and car B now had 15 gallons. So the question is, what was the difference in gallons of their starting volumes? So we need to see their starting volumes for car A and for car B at, let's say, time 0, right? Because this is at time 1 and time 5. Now, because it says that we're going to be using, we're going to see that this is changing linearly. Remember that if we want to write this in a linear function, um, visually, when we're graphing, we're calling this a slope and we're calling this the y-intercept. The slope is telling you the rise and the run of the line that you're going to graph. But in terms of a real world application, remember that okay, the slope is really corresponding to the rate of change. In this case, linear rate of change. Let me write that. The linear rate of change. Okay. And it's telling us if it's either going to be increasing or decreasing. So remember if m is positive, okay, that's telling you that you're increasing. And if m is negative, that's going to be telling us that this quantity is decreasing. All right. So we'll see. Notice that car A, the amount of volume of gas went down. So that is a decreasing rate. So when you're looking at these word problems and you'll get a slope, just make sure that you refer back to what it's modeling and see if it makes sense. Okay, and we'll do that in this one here. And then your y-intercept B, geometrically we're calling this the y-intercept. But in this case, remember that the y-intercept is telling you what is the y value when x equals 0, right? But in terms of a real world application, you're being asked, what is the quantity in this case at time 0? So normally it's the initial amount of that quantity that we're analyzing. Is the initial amount that this thing would be changing in, okay? And so this question is asking us, what is the difference in gallons of their starting volumes? So for car A, how much gallons of gasoline did we have? And for car B, how much gallons of gasoline did we have? So notice that because it's asking us for our starting volumes, it's really asking us to compare the initial amounts that they started with. So we can find the initial amounts using how the gas is changing per time using a linear function. And if we can find the B for car A and the B for car B, then we can just compare them and subtract them, and then that will give us our solution, okay? So what we need to do first is we need to use find the linear function for how car A's gasoline is changing per hour, and then how car B's gasoline is changing per hour, okay? So let's see. So let me just show you a visual here to kind of get an understanding, because in order to find your slope, you want to start figuring out what is like my x, what is behaving like my x, and what is behaving like my y, okay? So in this case, notice that given the amount of time, this is giving me the amount of gallons. But I found that when I show students who are a little bit more visual, sometimes kind of like a pretend graph, that can help you figure out what's X and what's Y by asking yourself, okay, um, am I looking at the amount of gallons and then that's going to give me the hours, or is the table telling me that a particular hour I have a certain amount of gallons? And notice that in this table, it's telling me that if I know the hours, so at hour 1, car A had 17.25 gallons. So the way I label this graph is in this manner here. And then notice that for car A, at hour 1, I had 17.25 gallons. So let's just pretend that's over here, 17.25. So that's going to correspond to this point. And after 5 hours, I now decreased to 14.25. So let's say that after 5 hours, at hour 5, it went down to 14.25. Okay, let's say this is 14.25 here. So notice that by looking at this table here, this graph, if I was to connect these two dots, notice that my graph is a line because it's telling me that it's going to be modeled linearly, and the line is going down as I go left to right. So notice that your slope is going to be negative, which is making sense because the rate of change is as decreasing rate. So remember that my slope should be negative. Now, let's say you wanted to figure out the slope. Well, the other reason I like to kind of make sure, sometimes you look at this visually is because mathematically, students are usually used to find the slope given 2 points, right? And so sometimes it's hard to figure out what are those 2 points because you have so much data on this table. But because you're trying to find the linear function for car A and then also another linear function for car B, you're going to focus on, if we're going to look at car A data, let's say this is for car A, you want to focus only on this part of the table for now and ignore car B. So notice that the hours are acting like the X values and the gallons are acting like the Y values. So you can either do it from this graph or on the table. Notice that you have the points for car A, you have the points 1, 17.25 corresponding to this part of the data. And at 5 hours, you have 14.25. And then also notice that this point is it gives you the coordinates of this particular point here, and this one gives you the coordinates of this particular point here. And so now you're going to use your slope formula here. So we're going to say, okay, to find my m, I usually do y2 minus y1 over x2 minus x1. You can think of this as the x1 and the y1. This is the x2 and the y2. So I'm going to plug in those values. So 14.25 minus 17.25 over, we're going to get x2, so 5 minus 1. And on the top, when you subtract that, you're going to get, I believe, negative 3. And on the bottom, you're going to get 4. Okay? So notice that that's negative 3/4. So you can stop here at this fraction. And since the y values correspond to gallons and the x values correspond to hours, this is telling you that you're losing 3 gallons for every 4 hours that you travel. Okay, so that's the way you can see it that way with that fraction. If you convert that into a decimal, that's going to be negative 0.75. And here, this is telling you, think of this as over 1. This is telling you that you're losing because it's negative 0.75 gallons for every hour. So you can look at it 2 different ways, okay? Per hour. And then this is or 3 gallons, you're losing 3 gallons. Oops, you're losing 3 gallons for every 4 hours. So it depends how you want to convert the fraction, okay? But in this case, let's say let's go with the negative 0.75. So in this particular case, we get negative 0.75, and we're not just trying to find the slope, we're trying to find the initial amount. So as you would with a normal, just purely mathematical question, you can use one of these points and plug it in to find your B. So for example, I know that my graph has to look like this. Let me use blue here. I know that my graph has to look like this, or sorry, my function has to look like this, and I need to find my B value. So what you could do is plug in any of these points, any of the X and the Y values here and here to help you find your B. So let's use this point here, okay? So let's say I'm going to use 1, 17.25, and I'm going to plug in Y for 17.25, 17.25, and then we're going to plug in X to be 1. So 0.75 times 1, let me do that in green. All right, and then I'm going to look for my B, okay? So this is the X value that I plugged in, this is the Y value that I plugged in into our potential linear function, and we're going to use that to find B. So let's see here. So we're going to get, this is just 17.25 times 1, it's just itself, plus B. So then we're going to add it on this side to get rid of it, 0.75. And then when we add that, you should get, I believe, 18. Yep. Let me change back to blue. So 18 equals B. So that tells us that our B is going to be 18. So we get, all of this tells us that for car A, my linear function that I'm using to model it is negative 0.75x plus 18. But it's the 18 that's important to us because it's telling us that the car started with, car A started with 18 gallons of gas, okay? Notice that because our slope tells us that it decreases by 0.75 gallons, well, if I start with 18, after 1 hour, I should decrease 0.75, which is why after 1 hour, it went down from 18 to 17.25 because it decreased by 0.75. So it's making sense. Okay, let's do car B now. So let me do a similar kind of thing here. So we know that now this is going to be hours in gallon. This is for car B. And the table tells us that within 1 hour, I have 19 gallons. So within 1 hour, let's say 19's up here, I have 19 gallons. And in 5 hours, I'll have 15 gallons. So in 5 hours, I'll have 15 gallons. Let's say that's over here. Let's just pretend. So again, if I connect this, if I connect this here, notice that it's also showing me that the line's going down. So my slope is going to be negative, which is making sense because the amount of gas is decreasing per time. So we want to see how much gallons of gas did we have at time 0, right? So notice that it's going to be somewhere above 19. So if I want to get the points as I did before, notice that we're going to have the point 1, 19, 5, 15. So let me write those points over here. So we got 1, 19 and 5, 15, which are the coordinates for this point and this point. And as I did before, we're going to use our slope formula here to find the slope of this line modeling this particular scenario. So m equals y2 minus y1 over x2 minus x1. This is going to be our x1 and y1. This will be our x2 and y2. So let's go ahead and subtract them. 15 minus 19 over 5 minus 1. So that's going to be negative 4 over 4. So that's going to be negative 1. And it's decreasing, which makes sense because we saw that the amount of gas is decreasing. And in terms of units, this is telling us that you're decreasing 1 gallon per every hour, okay? Or you're decreasing 4 gallons for every 4 hours, which is the same rate as this, okay? So again, we're going to find we want to find the initial amount, our B value, right? So I want to figure out, I know my graph has to, my linear function has to look like this. Oh wait, I think I had different colors last time. Has to look like this. So I want to use a point, either of these, and plug it in to find out what my B value is. Let's pick this one this time. So we're going to use, let's use 5, 15 here and use it to solve our B value. So let's see, y is going to be 15, and we're going to get negative 1 times x is going to be 5 plus b. So we got 15 equals negative 5 plus b. Let's go ahead and add that 5 to both sides. And notice that we're going to get 20 equals b, which is making sense because we saw that the initial amount had to be above 19, so it turns out to be 20. So we get, this tells us that car B can be modeled using this linear function, negative 1x plus 20. So you start out with 20 gallons, and then every hour you're going to decrease by 1 gallon, okay? But again, that's not, now we're going to actually answer the question. What was the difference in the amount of gallons at the starting volumes? Well, car A has 18 gallons, and car B has 20 gallons. So since car B has 20 gallons to start with, and then car A had 18 gallons to start with, we just subtract them, and then we get that the difference is they start with a difference of 2 gallons, where car B started out with more gallons. All right. So this part is not, I don't think, is the hard part. I think the hard part is finding these B values, these initial amounts. Okay. So just remember that when you're doing these problems, the rate corresponds to the slope. It's the rate of change of how this quantity is changing. And it's very important. For one way that you can check your work is if my slope is positive, that means I have an increasing rate. So it better reflect that on my problem. Or if it's decreasing, my slope needs to be negative. That's one way to check that you did your work correctly. Okay. And then don't forget that B in the real world application translates to the initial amount that you start with. All right? All right.